We are sketching a graph and we're indicating the axis of symmetry and the coordinates of the turning point. It's a quadratic. The quadratic is written in the reverse order. We normally think of quadratics as y equals ax squared plus bx plus c. But it's not too hard. They're just written in a different way. We can work out very easily that a is -1 is what is in front of the x squared. B equals 6 and c equals 17. Let's start with the turning point. The turning point is where x equals -b on 2a. And so that would be -6 on 2 times -1, which is 3. That's also the axis of symmetry, x equals 3. So we have the x value for the turning point. We want to find the y value. We just take 3 and put it back into the equation to find out what the y coordinate is, which gives us 17 plus 6 times 3 minus 3 squared. 17 plus 18 minus 9, which is 26. And so we know the turning point is at 326. Right, the y-intercept is really easy to find. It's just the c value. We know c17, so the y-intercept is at 0.17. The x-intercept, well, that's a little trickier this time. Let's rewrite it in the way that we're accustomed to, and we'd have -x squared plus 6x plus 17 equals 0. Now it's hard to, by factorizing by inspection is a lot easier when the a term is 1, but here it's -1. But we can turn it into a 1 quite easily by multiplying both sides of the equation by -1, and that would turn the whole equation into x squared minus 6x minus 17 equals 0. All right, if we're trying to do it by inspection, we're looking for two numbers that multiply to -17 and add to -6. Well, the only numbers that multiply -17 are 1 and 17, right? One of them has to be negative. But neither of those options adds to -6, and so we can't factorize this by inspection. What I want to do this time is complete the square on it. We could use the quadratic formula, and that would give us the x values that we're looking for. But let's complete the square as an exercise in using that technique. And to do that, we need the a term to be 1. Well, it is 1. That's very handy. We made it 1. And we're going to take half of the b term, square it, add it on, and subtract it. I like to write it like this: x squared minus 6x plus, in brackets, half of b, -3 squared. Of course, we're adding 9 there. We need to subtract 9, so it's -9. And then minus the 17, which was already there, which equals 0 still. All right. The reason we wrote it like that is we can factorize the first 3 terms there really easily into x minus 3 squared. That's why we wrote it like that, because we could do that. And then we're going to take the -9, -17, add them together, get net minus 26, and then take it over to the other side of the equation and make it just plus 26. All right, let's take the square root of both sides, and we'll get x minus 3 equals square root of 26. Don't forget, it's plus or minus. And then x is going to equal 3 plus or minus the square root of 26. All right, we need a calculator to help us with this. Who knows what the root of 26 is? We know 5 5s are 25, right? So it's going to be a little bit more than 5. Not much, just a little bit. If you didn't have a calculator, you could just adjust and work it out based on, well, it's a little more than 5. But since we do have a calculator, we're going to punch it in, and 3 plus root 26 is 8 point something. Let's make it, well, we're going to write it as 8.1. And 3 minus root 26 is -2. Let's write it as -2.1. All right, we have all the information that we need to graph this. So let's get some axes. Because the y value is quite large, 26, and x values are okay, 8 to -2. I'm going to make my scales different on the 2 axes this time. So on the y-axis, I need to get up to 26. I'm going to just make every 10, and so then I can see I've got 26 covered. On the x-axis, I'm going to make my scale just 1 again, because I can fit it up to 8 and to -2. When I just break every line into 1. And you can do that as long as you indicate what your scales are on the axis, you're fine. All right, we put the points in. Turning point is at 326, where it cuts the y-axis, where it cuts the x-axis. We try and draw the best parabola that we can draw. Give it your best effort. And don't forget to put in your axis of symmetry. And we're done.